All right, what are the magnitude and direction of the electric force on charge A? So this is our particle we need to look at. So we know there's a force of B to A or A to B, however you want to do it. And then there's also a charge of C to A, and then we're going to have to either add or subtract depending on their direction. So let's go yellow as being B to A. They are opposites, so they want to come together. So the from B to A would be that way, and then from C to A, they would want to go apart. So they are going to be in opposite directions, so we're going to subtract whatever they are. So I feel like we have to do two problems. We're going to have to do the force. I'll go with yellow first. The force of, okay, yellow is bad on a yellow background. A force of B to A, and that's just K Q1 Q2 over R squared. K is 9.0 times 10 to the ninth Newton meters squared over Coulomb squared. Yeah, I'm getting low. And then we can ignore, I converted that in my head, and I didn't leave myself enough room here. I converted in my head 1.0 times 10 to the negative ninth Coulomb, and that whole thing is over 1 centimeter, which would be 1.01 meters, and we have to square that bad boy. So let's throw that in our calculator and get 9.0 times 10, a lot of ones in there, yes, to the negative 5 newtons, and then we're going to have to do the same thing with C to A. Oh my God, am I sloppy? C to A. Same equation. I'll just fill in the numbers here. 9.0 times 10 to the negative ninth Newton meters squared over Coulomb squared. What are our charges now? We still have I'm ignoring it because I know these are attractive or repulsive. So this, I'll go back to this first one. We decided they were opposite, so this is attractive. It's just a direction. Attractive force. This one will be a repulsive force, correct? And when we get that, we know we're going to have to subtract them. All right, 1.0 times 10. I'm doing the charge A. Negative 9. Why negative 9? Because that's what nano is. You just kind of got to know these things. And the second one is 4.0 times 10 to the negative 9. And this one is not 1 centimeter away, even though you see 1 centimeter. It's C to A, so it's 0.02 meters, 2 centimeters. And don't forget to square it. And this would equal, throw that in your calculator. Since the distance changed and the charge changed, if you notice this doubled, that got cut in half, it's going to be the same number. 9.0 times 10 to the negative 5 newtons. And then what we have to do is, I'll go to a different color. We are going to add them up, and since they're the same, or add them up, we're going to subtract. Repulsive, one would be towards the left, so that one would be negative, this one would be positive. They're the same number, subtract same number, and you get 0. Answer is 0. Woo woo, woo woo.